Wow, I'm happy to have you here once again. I'm still your friend and your brother, and also your tutor, Engineer Ike Okechukwu. Welcome once again to Physics Meal. Physics Meal is a program under Science Tutorial. Science Tutorial is a platform that we use to improve the study of sciences among students. This edition of Science Tutorial is a special edition because we are using it to prepare students for 2021 WASI examination. We have done a lot of revision classes through this forum, and today we have another fantastic topic and lovely topic to look at, and that's on wave. Our attention today will be on calculations involving wave. When we talk about wave, we have different aspects. So we're going to look at the basic calculations from wave. Now, that's the basic calculations on wave. Now, before we proceed to this basic calculation, before we start solving problem, it will be necessary for us to write down some important expressions that we will need. There are so many expressions that we're going to encounter in solving problems in wave. Yes, there are so many of them. So the preliminary calculation, that's the basic expressions, we're going to write them. Then we use them for various calculations. Just follow me as we enjoy ourselves on wave. Can you wave your hand? Just wave your hand wherever you are because we're about to do what? To do wave. Don't mind me. All right, let's begin this journey. Even as you're waving your hand, but you can now stop waving your hand because you're about to write. But you can still be waving your hand with your left, and if you are using your right hand to write, and then you can use your right hand to wave if you are using your left hand to write. But just stop waving because it may lead to distraction. But just know that we are about to look at calculations in wave. All right, let's begin. There are some expressions that in our videos, when we treated wave as a topic, we generated those expressions. Now that we want to do calculations, there is need for us to recall these expressions so that some of us will not be confused. Maybe you have not watched that video, so you will not be confused in the course of looking at these expressions. So join me as we record them. We have one expression that the period of a particle involved in a wave motion is equal to the time over number of cycles or number of oscillations. We also say that the frequency is the number of cycles divided by time. We also arrived at the concept that the lambda is equal to the distance over number of cycles. That's what we call the wavelength. We have that. We also have another expression that the linear velocity or speed is distance over time. We have another one that the angular velocity is theta over 360. Yes, we have that expression. This is what we call omega, the angular velocity measured in radians per second. Because in wave, just like we have in circular motion and simple harmonic motion, we discover that we have angular speed and linear speed. So this is the angular speed in wave. So we have the sixth expression. We have that t is equal to 1 over f, and if t is 1 over f, it also means that f will be equal to 1 over t. We also establish that v is equal to lambda f, that's the wavelength times frequency that is measured in hertz. Oh, there are so many expressions. We also have that 9, that v is equal to lambda over period. We also had another one that omega is 2 pi f, that's angular velocity is 2 pi f, and then we have that omega again is 2 pi all upon the period, So we had all these expressions. There are some that you may not actually see, but let's put down this again. Number of lambda, number of wavelength, is number of crest minus 1. Number of lambda again is number of troughs minus 1. There are other important statements that we made concerning wavelength. We say that a wavelength is 1 circle, or the distance between 2 points, successive points that are in phase. We also say that the distance between successive crests or successive troughs is a wavelength. When you watch the video on the introductory part of wave, you are going to understand it. So some of these expressions, some of these terms, these symbols, you are familiar with them if you have watched the video or if you have actually had a class in wave. Yeah, you'll be familiar with all this. So the purpose of this class is for calculation. So we will not go back to start looking at all these one by one to explain what they mean, right? So when you watch that video, it will also help you a lot to understand what these symbols are all about. All right, we just have about 13 simple expressions, just 13 of them, very simple, that we can actually use in carrying out our calculations. All right, let's take one question quickly, a very simple one, just one question, then we'll take it and we'll move on. So let's look at example 1. Example 1, let's say that. They say a radio wave has a wavelength. Let me use here where we have space. A wavelength of 150 meter. If the velocity of radio wave in free space is 3 times 10 raised to the power 8 meters per second. Calculate the frequency of the radio wave. Oh, beautiful. That's nice. So a radio wave has a wavelength of 150 meter. If the wave velocity of radio waves in free space is 3 times 10 raised to the power 8 meters per second, they say calculate the frequency of the radio wave. Calculate the frequency of the radio wave. Now, when we are solving problem in physics, we usually use the principle of I see. If you can see, you can actually solve problems. If you can see, we'll say that I means identify, set it up, exploration, as if you are searching for oil exploration, then you execute. I wish you will see in the course of watching this video, and your life will no longer remain the same in physics. Your life will be beautified in physics. So a radio wave has a wavelength. So we identify and set up. When you identify the things given to us and what you are asked to calculate, set it up using the appropriate symbol. So they say a radio wave has a wavelength of 150 meter. So wavelength, I have identified the wavelength. What's the symbol? That's this, lambda equals 150. I'm setting it on. They say if the velocity of radio waves in free space is this. Now remember, we have two velocities, angular velocity and what? The linear velocity. But angular velocity is measured in radians per second. So yeah, radians per second. While linear velocity is measured in meters per second. So using this unit, we know they are talking about what? The linear velocity. And the symbol here is V. 3 times 10 raised to the power 8 meters per second. Okay? And we're asked calculate the frequency of the radio wave. We are looking for frequency. That's the symbol. We don't know what it is. So we have been able to identify the parameters or the variables given to us, and we also have to set it up using the appropriate symbols to represent these quantities. So the next thing for us to do is to start searching. The exploration. We explore. We start searching from the list of the equations that we have or expressions that we have, how which one will be suitable, or what you may call formula that we have, which one will be suitable for calculating the frequency. Remember, based on what has been given to us. So if we come here, we have frequency here, but we don't know N and T, so I can't use it. I have frequency, I don't know the period, I can't use it. Then I say another place I have frequency. I have frequency here, but we don't know this, I can't use it. But look at this. We have V. V is equal to lambda F. I know V and I know lambda. The only unknown is the frequency, so I can possibly use that. So F becomes what? The velocity over what? Lambda. So what is F? 3 times 10 raised to power 8, all upon 150. Because V is this and this is that. So somebody will say, what am I going to do? You know, mathematics is beautiful. Some of you that, if you don't know what to do, you just start pressing calculator. So I can still write this in my own way. Yeah, in my own way. Let me do this. I can write this as 300 times 10 raised to power 6 divided by 150. That's what I've decided to do. Somebody will say, why are you doing this? Because 300 times this, these two zeros will still make up this. Just know how to solve your problems and make it easy for you. So that when 150 divide 300, I will have to, I've just seen that. I've just seen that. Someone can still say, let me divide 3 divide this, 3 divide this 50, and still go on to divide to arrive at the answer. Somebody will have 300 million divided by 150. You still have that in your calculator, but I don't have any with me here, so I have to start doing a lot of manipulations. I have to try as much as possible to do a lot of things in order to arrive at my answer. Definitely the answer will still be correct. So when 150 divides 300, I'll be left with 2 times 10 raised to power 6. The unit of frequency is what? Hertz. That's the SI unit. Remember, dimension wise is per second. So 1 hertz is something as 1 per second. 1 per second. So that's our frequency. That's our frequency. So you divide this, you have this 2 times 10 raised to power 6 hertz. That's the frequency of that radio wave. Oh yes. So we still have many questions, many more questions to look at. So we have to take one more and then we'll go on a break. We'll take one more and then we'll go on a break. So let's look at example 2. Example 2. Example 2. Oh, how's that? Operation number 2. Example 2. They gave us this. Other. They said the diagram shows an electromagnetic wave, shows a transverse electromagnetic wave. If the period is 5 seconds, find the velocity of the wave. So the diagram shows a transverse electromagnetic wave, and they say if the period is 5 seconds, find the velocity of the wave. Quickly, let's identify. What did they give us? From here to here is just a distance, 5 meters. And we represent distance using x. So x is 5 meters. Now, what did they give us again? They gave us the period, capital T, equals 5 seconds. And they asked us to find the what? The velocity. Somebody is already dancing. Oh, I know the answer, I know the answer. We just use 5 to divide 5. Cool down. Look at this. Remember, we have v is equal to x over t. This is small t, but what we have here is period, capital T. So how am I going to do that? If I must find velocity, since I can't use that x to this, the other places we have this are here and here. So I know period. If I will find velocity using this period, I must know the what? The lambda. So there is something else given to us that we are not seeing. Let's write it down. I purposely omitted it. That's n, a number of circles. How many circles do we have here? This and this 1 circle, this and this 1 circle. So from here to here is 1 circle, 2 circles. So I have 2.5 cycles, which is 2.5 what? Cycle. So having done that, one can easily find the wavelength. So I can find the wavelength because if I want to use v is equal to lambda over t, because I know period, I need to find lambda. Then I ask myself, do I know any parameter here that can help me to find the wavelength? Yes, I know x and the what? And n. And we have said that lambda is what? X over what? N. So I can use that and find lambda first. What's x? 5 all upon 2.5. So lambda becomes 2.5 divided this will give us what? 2. That's what we are going to have, 2 meters. Beautiful. So V becomes what now? Lambda over period. I have calculated lambda using the x and n given to me. What is that? 2. All upon the period was given as what? 5. When 5 divided this, I have 0.4 meters per second. Alright. As you continue to ponder on this, we need to go on a short break. And when we return, we'll continue with more calculations on wave. Thank you and remember this.